Glider 4-3 Flight Instruments. Today we delve into the intricate world of variometer instruments, indispensable in providing pilots with crucial information about the vertical ascent or descent of the local air mass and glider. Picture this as a speedometer for altitude, a vital component within the glider's instrument display that aids our pilots in understanding the performance of the glider as it soars through the atmosphere. Now, the principles of operation here mirror those of our trusty altimeter. The variometer becomes the watchful eye of the glider pilot, depending on the pressure lapse rate in the atmosphere to discern vital details about the rate of climb or descent. In the realm of non-electric variometers, a separate insulated tank, often a thermos or capacity flask, takes center stage as the reference chamber. This chamber, connected via tubing to an external static port, forms the backbone of what we call the uncompensated variometer. Its rapid response is owed to the small mass and lightweight construction of its moving parts. As pressure nuances play out between the variometer's internal chamber and the surrounding environment, air flows, dynamically illustrating the climb or descent on the variometer needle. In moments of level flight, the variometer maintains its composure, while the needle changes with the glider's ascent or descent during climbs and descents. In fact, specific flight maneuvers trigger fascinating changes in altitude readings on this uncompensated variometer, offering a dynamic insight into the glider's journey through the skies. Now, allow me to introduce you to the realm of electric-powered variometers, which come bearing their own set of advantages. Rapid response rates and distinct audible signals for climb and descent add a layer of sophistication to their functionality. Some variants operate on the intriguing cooling effect of airflow on a thermistor, a heat-sensitive electrical resistor. Picture this. As air flows in or out of the reference chamber, it gracefully caresses two thermistors in a bridge circuit, creating a dance of electrical resistance changes. The meter calculates the rate of climb or descent, elegantly displaying this information on the variometer. For the modern aviators among us, electric variometers offer the convenience of audible tones or beeps that graciously convey the rate of climb or descent. This auditory feature not only enhances the safety of flight but liberates the glider pilot from constantly peering at the instrument, allowing them to allocate more time to observe the surrounding airspace for potential traffic. Now, imagine a variometer equipped with a McCready ring, a rotatable rim speed scale that reveals the optimum airspeed for maximum cross-country performance between thermals. This ingenious feature allows pilots to set the index arrow at the expected rate of climb in the next thermal, guiding them to the optimum speed to fly between these soaring columns of air. In our journey through the skies, it's essential to note that variometers are indeed sensitive beings, attuned to changes in pressure altitude induced by airspeed. The stick thermal phenomenon, where a dive indicates descent and pulling out of that dive signifies ascent, paints a vivid picture of the variometer's responsiveness. In gliders lacking compensated variometers, maintaining a constant airspeed becomes paramount for accurate variometer readings. Now, let's shift our focus to the intriguing realm of total energy systems integrated into variometers, a sophisticated addition to our glider instruments. These systems play a pivotal role in mitigating the impact of airspeed changes on climb and dive indications, colloquially known as stick thermals. Why, you may ask? Well, the glider pilot desires a clear understanding of how swiftly the air mass is ascending or descending, irrespective of fluctuations in airspeed. One prevalent total energy system employs a small venturi mounted in the airstream, intricately connected to the static outlet of the variometer. This setup, akin to a finely tuned dance, harnesses the principles of increased suction when airspeed rises and reduced suction when it decreases. As the glider maneuvers through the skies, this dance serves to offset climb and dive indications triggered by airspeed alterations. It's crucial to note that for optimal precision, the total energy probe must bask in undisturbed airflow, ideally situated ahead of the aircraft nose or tail fin. An alternative total energy system introduces a diaphragm-type compensator strategically placed in line from the pitot tube to the line stemming from the reference chamber. This diaphragm, ever responsive, modulates pressure changes in the reference chamber based on the effect airspeed changes exert on pitot pressure. When delicately calibrated, this compensator proficiently conceals stick thermals. Now, let me introduce you to the Netto variometer system, a fascinating concept indeed. This system takes us beyond the glider's climb or descent rate, focusing on the vertical movement of the air mass itself. Some Netto variometer systems incorporate a calibrated capillary tube, acting as a miniature valve that skillfully removes the glider's sink rate at different airspeeds from the variometer indication. It's akin to sculpting the variometer's response to present a clearer picture of the air mass movement. In the modern era, we encounter computerized, electronic, Netto variometers, ushering in a new age of precision. These systems, equipped with sensors for both pitot pressure and static pressure, relay airspeed information to the onboard computer. The computer, armed with the glider's sync rate data at various airspeeds, performs intricate calculations, revealing the rate of ascent or descent of the air mass itself. It's a symphony of technology ensuring our glider pilots stay well informed amidst the dynamic dance of the skies. Now, transitioning to the electronic flight computers, an integral part of gliders involved in competitions and cross-country soaring. These computers, devoid of a generator or alternator in non-powered gliders, draw power from sealed batteries or even solar cells, demonstrating the marriage of technology and innovation. At the heart of these flight computers, we find an electric variometer, a coupled GPS receiver, and a microprocessor working in tandem. This trio crafts a symphony of information, providing the pilot with details on position, altitude, speed, and aiding in decision-making during cross-country endeavors. Picture this. The GPS-coupled flight computer becomes a virtual co-pilot, offering insights into the glider's journey, from where it's been to where it's headed, and the nuances of the environment it traverses. The flight computer, through its electronic audiovisual variometer, constantly communicates the rate of climb or descent, offering both visual and audible cues to the pilot. This dual input system ensures that the pilot, even when not fixated on the instrument panel, stays attuned to the glider's performance. Furthermore, the flight computer assists in optimizing airspeed based on various factors, freeing the pilot from extensive speed to fly calculations and allowing them to focus on the broader aspects of flight. As our journey unfolds, the presence of water ballast emerges as a game-changer, altering the glider's performance characteristics. Flight computers gracefully account for this, adjusting speed to fly computations in real time based on the weight and performance nuances introduced by water ballast. In essence, these electronic marvels adapt to changes, ensuring a seamless and informed flight experience for our glider pilots. In conclusion, these intricate instruments, from total energy systems to electronic flight computers, stand as testament to the marriage of technology and aviation prowess. They empower our glider pilots with a wealth of information, transforming the skies into a dynamic canvas where precision and performance dance in perfect harmony. If you click like and subscribe and leave a comment, we will provide a coupon for a free PDF download, one of 9 ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.